Before I go through this question, I must say, right, this question is fundamentally problematic. Okay, to do this question, to get to the answer, I'm not explaining the physics. I'm explaining how you can get to the answer. Okay, and this is a terrible question. Yes, some bad physics inside, but I'll just illustrate to you. If you want to just skip this problem altogether, it will not appear in exam. Okay, so let's just go through this. You have an atom X, right, excited to an energy level E2 from ground state E1. Okay, so this is X. Yes, a certain energy level, so this is 0. You see, every time I draw 0, because right, I need you to realize that all the excitations are talking about levels below the 0 energy level. Okay, so this E2 and this is E0. Okay, so this guy, right, is like making this jump. Okay, yeah, so and what caused this guy, right, to gain this energy? Well, it is another atom come in, right, and collide with this guy. Okay, so this guy will gain how much? Will gain E2 minus E0. Similarly, right, this guy must lose E2 minus E0. Okay, yeah, so what energy, right, must Y possess before the collision? Clearly, right, A is out, because it must be at least E2 minus E0, right? Okay, but let's say, right, this guy only has suppose, right, energy of Y is just E2 minus E0. What does that mean? That would mean, right, this guy's KE final will be, let me just indicate, KE final of Y, right, will become 0 because he will lose all his KE, all give to the X. Then what happened to the KE final of the X? KE final of X. This will also not be, will also be 0 because, right, X will gain this energy, excite, and simultaneously, right, de-excite back and give out a photon. Okay, and thus, right, it will still have no KE. Yeah, and since, right, they have both 0 KE after the collision, their total momentum will have been 0. Okay, but, right, Y actually comes in with some momentum, momentum of the initial momentum of Y is actually non-zero. Therefore, this means that the principle of conservation of linear momentum is violated. At first, this system got a non-zero momentum, but using this number, this system must end up with 0 final momentum. Okay, and that must not be the case. Therefore, right, okay, C is not possible. Okay, which means, right, that so let me just cross this out. This EY must be some value which is not must be greater than E2 minus E0. Okay, such that, right, this one will be non-zero, this one will also be non-zero. Oh, sorry, this one could still be 0, but here, right, the final momentum will be non-zero. Okay, and that will leave it some options, right, how conservation of momentum may work out. Okay, so that will be option D. Okay, I'm so sorry, I made a mistake here. So I'm saying, right, that here in this process, right, the Y must have given X, right, more energy such that the final KE of X, right, is non-zero, and both of them, right, could have a combination of KE and momentum that allow the conservation of linear momentum to be at play. So what I mean is here must be greater than E2 minus E0, here must be non-zero. Okay, If you find all of this explanation, right, quite challenging to understand, just ignore it. This is a flawed question, will not come out. So you do not need to understand any bit of what I say just now. Alright.